Welcome to Elevate AI Architect Skills. I'll introduce your presenters. Carrie Holly. Carrie Holly's pioneering journey spans from punch cards to today's AI revolution, leading breakthrough innovations across every significant computing paradigm. He's a retired IBM fellow, and his exceptional contributions and innovations earned him induction into the National Academy of Engineering and the National Inventors Hall of Fame. As a tech executive at Google and VP CTO at Cisco, Carrie drove enterprise scale innovation. In healthcare, he led an AI innovation at a Fortune 5 healthcare company, and his expertise is captured in his latest books, LLM and Generative AI in Healthcare and AI First Healthcare, both part of his extensive portfolio of published works on technology. Bill Brown. Bill Brown is a seasoned technology executive with many years of experience in global C-suite leadership, specializing in digital modernizations and transformations, cloud-native, domain, and event-driven architectures, governance, and AI solutions. Currently serving as founder and CEO of a product development and consulting company focused on AI development, Bill provides strategic direction and solutions that help Fortune 1000 enterprises meet critical business imperatives, address technical debt, and successfully adopt emerging technologies. He's a published author and has over 90 patents. He's an IBM Distinguished Engineer Emeritus. Welcome, Carrie and Bill.
Thank you for that kind introduction. And as you guys, friends know, this is a class about how to elevate thinking as an architect in the era of AI. So with that said, some quick caveats. We're going to be fast. It might feel like a water hose, but I promise your thirst, I believe, will be quenched. We might go longer than the 30 minutes because we are going to have an optional Q&A. So anyone who wants to hang around for or until the top of the hour, you're welcome to do that, and we'll answer questions at that time. Screenshot anything you want. Everyone will get a recording, which will be a few days afterwards. I think they give about 3-4 days for the recording to get populated. And as I said, we may go longer than the 30 minutes, and we'll have the live chat. Meet each other in the chat, talk, and let's get started. So the picture you see here is a picture about the future. So what you're seeing here is you're looking at the evolution that's happening right now. In 2022, we had these standalone large language models. ChatGPT brought this into the public's attention. Basically, essentially prompt in, answer out. But by 2023, a little known fact, compound AI systems started to appear. I'll define those shortly. But basically, they combine large language models with a variety of other things, memory tools, workflows. And then in 2024, last year, we saw the rise of AI agents. And now we're moving toward generative agents and multi-agent systems. And we'll talk about all of that. But notice what you're actually seeing on the shift. The shift is on the left, the simple input and output. And on the right, reasoning, memory, complex control logic. And this growing complexity is exactly why Bill and I believe that architectural thinking is critical. So today we'll focus on what it means to think like AI architects. The public, the media, and even many AI pundits throw around the word AI the way we talk about, they use it like we would use the words transportation or energy. You'll hear statements like we need more transportation to fight climate change. But what does that actually mean? Cars, trains, electric scooters, each one has different costs, trade-offs, and impacts. And the same thing is true with AI. The fact that we use AI in the same way we use these other generic terms, transportation, energy, as examples, is problematic. People say we need more AI, we're doing AI, without clarifying what do they actually mean. Are we simply talking about prediction models using machine learning? Are we talking about more richer prediction models using deep learning? Are we talking about chatbots? Are we speaking about generative model or full-blown multi-agent systems? This vagueness is not just problematic for conversation, it has real consequences. It leads to mismatched expectations, often between executives and consultants, executives, and practitioners. It can lead to failed pilots, wasted investments, and executives walking away disillusioned with AI altogether. And we're beginning to see some of that. Um, some of you who saw some of the advertisement for this session saw that we put a link about the RAND Corporation, about why they say AI projects are failing. If you look in the chat, you'll see a bunch of links in there that you can link at your discretion, but one of them is that RAND study. We also know that a lot of AI adoption is occurring, but again, it begs the question, what do we mean by AI? So a lot of people, when they talk about AI adoption today, they're talking about the adoption of large language models and generative AI. So corporations at large have been adopting AI for some time, but now let's try to be a little bit more specific. And toward that end, uh, we developed this framework that I'm describing as AIScape. So this framework is not a maturity model. It's not that you're better or worse by being at 0 or 7. It's simply a way to have a useful, productive conversation when we talk about AI. So we can be a little bit more specific because each of these types of AI systems has different cost trade-offs. They actually mean different things. I'll give examples of all of these momentarily, but there's also different artifacts, some which are optional, some that are mandatory. For example, you'll hear me talk about this multiple times. One of the early systems the IBM company built called IBM Watson deployed in one of its instantiations at a large hospital in Texas. It really was a type 1 system. But a lot of people, when they talk about the failures of AI and they use that as an example, they think maybe there were AI issues. That particular system was very traditional machine learning, used natural language processing. But the big challenge was that even though it was a traditional ML system, the nature of it, and that's not true with all traditional ML systems, like predictive models, have very little need to manage the organizational change aspects in an organization. But when you're dealing with a hospital and changing the way doctors and nurses and other clinical people work, change management becomes critical. And that was one of the root causes of failure. But the message here is that each of these types of systems, like type 0, these are basically rule-based systems, statistical models, decision trees. This is the implementations of AI that we saw in the 60s and 70s. Then type 1. Type 1 is where we started using very specific algorithms, SVMs, XGBoost, all of these things that those of you who are data scientists or people who've taken statistics or machine learning have begun to learn. But these type 1 are very task specific. What people often described as narrow AI versus what people are trying to get to today, or what the industry is trying to move to today, which is general AI. And then type 1 is when neural networks, this is where the term deep learning became vogue, but neural networks, perception tasks became the thing going on here. And then type 5, which is more out in the future, became goal directed, multi-step reasoning. So we're going to talk about this framework in a little bit more as we progress here. But I also want you to know there is a link in the chat that has a more detailed article, and there'll be more articles published to describe how this framework can be used. For example, it can also be used as a learning progression tool. Like if you wanted to start at type 0 and 1, master the fundamentals of statistics, traditional machine learning, data pipelines, that would be where you start. Then you would move to type 2 and 3 to develop knowledge around deep learning and large language models. So the other thing to note here is that just to be clear, type 3 is what we saw when ChatGPT was initially announced. It was a foundational model. We saw open source examples. We saw Anthropic's Claude. We saw Google's Gemini. We saw Perplexity. So we saw a lot of foundational models get introduced. And then later, very rapidly, we saw these models get augmented. They got augmented in some cases with their ability to access the internet or to use APIs, but they became, and to use things like RAG to use external data sources. So they became tool augmented. That's what took them from 3 to 4. And then, of course, 5 is where this notion of AI agents came into play. So AI agents are goal directed, there's multi step reasoning, and this notion of compound AI systems. Again, in the chat, there is a video, a YouTube video talking about what compound AI systems are, and a blog post on that as well. And then, of course, 7 is more aspirational. Let's go back a slide, though, for a moment here and just take a view of this picture. What you're seeing in this picture on the right is where we are today in terms of a lot of the excitement. You'll notice that an LLM sits at the center, which is being used for reasoning. Even though I put LLM as the reasoning tool of an AI agent, keep in mind other techniques that we saw with tools or implementations like AlphaGo can be used instead of LLMs. But the point is, what makes it an AI agent is that you are using AI, um, some type of AI technology for reasoning. So that's what makes it there. You're using tools. Tools, as I said, could be external systems. They could be what we know as microservices, any type of API invocation to something else. And there may be some control logic. That control logic may be human controlled, or it could be controlled by an agent, an AI agent. And although it's not the purpose of our course here to teach all of these concepts, it's really to put this in your awareness loop so you begin to think like an architect. So hopefully I've given a good description of type 0 through 7. We'll give some examples in a moment. So what is architectural thinking? Architectural thinking truly is a approach it differs than design. Architecture thinking is largely broader. It's often thinking about the future. It's often thinking about the things like future proofing. It involves understanding constraints. It's a paramount skill to move the discussion away from our personal and biases and preferences to reasoning systematically. That's what architectural thinking is. So this active debate, as an example, uh, some of you who are deep into AI are pretty aware that there's a lot of debate about single agent versus multi-agent. There's been a debate by a company called Cognition AI in terms of whether this notion of agentic meshes is something that has a technical foundation. And my point of view, our point of view, Bill and I, is that a lot of the thinking in that area might fall into a type 7, which is very experimental. But the point is, whether you use a multi or single agent deployment really depends upon the problem that you're solving. So architectural thinking is a way of approaching problems by considering the big picture, understanding trade-offs, understanding constraints, whether they be timeline, monetary, people, resources. But it's also about translating business needs into architectural solutions. It's not just about designing systems, it's about understanding context, shareholders, long-term implications. It's a mindset that involves analysis, synthesis, evaluation, with the focus on creating value. So that's what this 30 minutes is about. It's about architectural thinking. Now, in our bigger course, which is over 3 days, we cover this in much more detail because there's a ton of issues here. There's an active conversation around software 3.0 versus AI agentic mesh, what McKinsey is saying versus what the technical industry is saying. We'll get into those issues in the bigger course. Don't have the cycles to do that in this course. So let's go back and uh, hopefully you've got a good picture of what architectural thinking is. I thought I would share with you a couple of these are actually very recent posts. I removed the names here, but this is a post by a pretty talented person at Google, and it was on Twitter. And they wrote, "Hey, at Google, we're moving from a writing first culture to a building first one." I just want to, I mean, although this context, to be fair, was in the context of consumer-based apps and building products. versus an enterprise app, although the message I think translates. But basically, what they're saying here is that because of the new tools that we have with things like vibe coding, now we can actually build faster than we can write. So instead of writing a product requirements document, a PRD, let's just build, let's just get in there and code. So it reminds me, Bill and I both worked at a company where one of the top executives who reported to the CEO had a famous line about, hey, PowerPoint drools, code rules. So there's an active tension that's been with us for decades, where there's a frustration with this process center view of development. And I'm all on board with that. We don't want a heavy process centric view, but we can't ignore the clarity that comes from thinking. So that's the point here. With that said, there was a friend of mine. He may be on the call, but Scott had a point of view here, which was that, well, number one, the big company of Google has never been a writing first culture. And point number four, you got almost 200,000 people at Google, and maybe some people are right first and other people aren't. But the point is, you can't generalize about a company. But the other point he said here is trying to build something real from a from a program manager's prototype. He described as a specific type of hell. We're each going to have our experiences. But the real message I want to take away from what Scott wrote was number two. Prototyping is not a proxy for clear thinking. So when do you do the clear thinking? I would argue you do it when you think about the architecture. So in some products that you build, the product is already going to sit in a given infrastructure. It's going to sit within an architecture. So maybe you don't have a lot of work there to do an architectural thinking. In other cases, you do. So I just want to acknowledge that it depends. So that was the message there. So why did we build AIScape? We built it, we thought about it because of, and there's another video that I didn't put the video, but a YouTube link that's in the chat. Again, this whole conversation about AI, I really think it's critical that when you have conversations, that we know what kind of AI system we're talking about, because they're each different, these types 0 through 7. And they will require different levels of architectural thinking. Don't have the cycles to cover that in detail, but that's the message. So which kind of system are we building? That'll lead us to understand what level of artifacts, whether those be business artifacts, whether they be architectural artifacts, we'll be able to understand those when we understand the kind of system we're building. Now, I recognize for some CTOs and for some very experienced AI architects, this is going to come natural to them. They don't need something like AIScape to tell them that. But for others, maybe those who are on the business side, those who are on the project manager side, those who are growing their architect skills, this could be an invaluable aid. So this picture hopefully will ground into you some clarity into what is AIScape. So many of you have heard of Deep Blue, which was the chess-winning computer back in I believe it was in the early 80s. But that's a type 0. Didn't use any machine learning, didn't use any deep learning. LLMs were in a nascent stage back then, all rules-based. Spam filters, these are early spam filters, all early examples of type 0. A lot of statistics, a lot of probability, a lot of rule-based. Then, of course, we saw the arrival of machine learning, financial services and healthcare, insurance. These were three big industries that just jumped on this notion of um, of of machine learning in this case. But the point is that that's what they were, type 1. Then we had the AlphaGo, and I think I've covered a bunch of this. So in the interest of time, let's move on here. So what you see here is, and I thought this picture would be useful because what this picture is showing is the types of changes that we're seeing Uh, ChatGPT represents an example of this. So ChatGPT started as a standalone, a type 3, moved when it started adding tools, GPT-4 to a type 4, and then today type 5 with the agents and memory. But it's looking to move to type 6. But type 6 is not going to be something that a consumer is going to actually take out of the box. It's the work that ChatGPT, OpenAI is doing behind the scenes with enterprises. So the deployment of this ChatGPT enterprise for many companies that will use that deployment, that will result in a type 6. And this picture here, again, is just trying to give you a view that I'm going to focus on one column on the right, the organizational change management. But again, you can see the different types of artifacts, the complexity of the architectural overview, and these type 0 and 1s might be one page, one picture. And a type 6 is going to be more complex. Change management going to differ based on whether we're dealing with business versus consumer, because with a consumer app, we're dealing with user communities, we're dealing with adoption, we're dealing with trying to grow the user base. In a business app, we're dealing with more transformational change at an organizational level. So again, the level of complexity of these documents will vary. With that, Bill, the floor is yours.
Thank you, Karen. Thank you for that great first half of this class. I know we're running up against a time constraint, so I will not be my typical long-winded self, although I'm starting that already. So, as we talk about this particular approach, a reactive approach versus a systematic approach, I think we would all agree that thinking through what you're going to do before you actually do it is usually a good thing, right? I know growing up, my grandfather used to always say, think before you leap. And certainly that's kind of where we are here with architectural thinking. Um, Taking a systematic approach has some defined benefits, right? You understand the problem better, you make better decisions, you are able to correct those decisions before you make expensive mistakes. You can move on to the next slide. So for an example, right, and we'll use this in the context of a customer service AI solution. A reactive approach would be, hey, well, we need AI for customer service. Let's implement the latest LLM chatbot through ChatGPT. Let's go out and buy some tools, and then we'll figure out how this works later. The result is going to be one, chaos, a number of expensive mistakes that you'll have to redo, and you'll start your development of your technical debt. So the things that you'll have to go back later on and correct and probably redo. In a systematic approach, the things that you'll think through will be, okay, we need this customer service. It is for ticket resolution. We'll need account access. We'll need to escalate to humans when we need to do that. What kind of or what type of architecture will this need? And so, referring back to AIScape, we can probably find, or we will look at the correct type and then apply it. Again, I'm thinking through, I'm taking a strategic approach to building my systems. The result will absolutely be a better system, a better, quicker adoption by its users, and certainly less expensive mistakes as you move forward. You move on to the next slide. So, as we talk about assisting ourselves in thinking architecturally and assisting others that will come on after we start a project.
Recording in progress.
Um, we typically talk about architectural artifacts. And really, I've put up three, right? I put up an architectural overview, architecture decisions, and a change management document. We move on to the next slide. We'll briefly talk about architecture overview. So you can flip to the next slide.
Oops.
Great. Yep, good. So as you can see, I put up a table of contents of a typical document. But what you should be thinking about as you put this together is how can I um, create a document that will bring the rest of the team up to speed, keep everybody on the same page. And so that document needs to describe the system. It needs to describe the what of the system in both business and high-level technical terms. And then, depending on the type of AI solution you're putting in, this document will be long or short, depending on how you're trying to implement it. But the more complex systems, the type 5, 6s, this will probably be a fairly detailed document. Those that are types above that, then certainly you won't have to cover a number of the things that you'd cover in the more complex one. But again, the idea of this is to strategically think through what you're getting ready to develop and why, what this system will do, and again, for the folks that are coming on or for members of your team that come on after the start, this serves as a guide to get them up to speed quickly. It also serves as a guide to get your business partners, your execs, your sales teams, all your stakeholders on the same page with what you're doing. You can move on to the next slide, Carrie. And we'll talk about architectural decisions. Now, in most cases, and Tony Corrado will agree with this as well, a lot of people, when they're developing a system, they leave these kind of artifacts as an afterthought. So they'll put them together, they'll do the documentation after they make their decisions or after they're finished. The reason that is problematic is, again, it doesn't fit into this strategic approach of building your system and thinking it through. But also, you'll lose a lot of perspective when you look back at this after the system has been done. So what we're trying to do or what we need to do with architectural decisions is understand the subject area or the context of the problem or the issue, discuss and introduce options to address it, talk about the trade-offs for each and every one of those options, the pros and the cons, and then come to a solution with risk mitigation strategies, but also talk about why I came to this decision. Why is this important? This is important so that a year from now, when I look back at this system and there is a new a business directive or new technology, I can go back and I can understand why I made the decisions I made up front. So again, I am thinking this through. I am taking a strategic approach. I am documenting my concerns, and by doing so, then I don't have to repeat that same process again sometime in the future. We can move on to the next slide. Excuse me. And the last document we'll talk about is change management. Carrie and I had a discussion about this just yesterday as we looked through some of the change management documents or change management plans. And they're going to be different depending on the perspective you come at it from or the system that you're building. From a business approach, The change management plan is going to be all about getting buy-in, doing organizational change management, getting the team on the same page. But from a consumer perspective, if you're rolling out a product, you're developing a product for consumers, then change management is going to be more about adoption, more about the user interface, more about how I iterate based on the feedback I get from my users to make my product better or my continuous improvement process. That being said, what we're going to focus on in the next slide, and please go to the next slide, will be the change management from a business perspective. And you guys can read this like I can. I won't read it to you, but extremely important to come up with a communication plan that is part of this change management plan that provides transparency to all the stakeholders that are involved. And the main thing that you want to get across, the main concern that you want to alleviate and make sure you address is helping everybody understand what's in it for them with this new business app and with this new focus. The reason you want to do that is because you want adoption. When people understand why this will benefit them or how this will affect them, then they're more likely to adopt this, which makes the success of your system more of a good possibility. We can move on to the next slide. So, a topic that Terry brought up in the AIScape discussion, as we talked about different types, we wanted to give you an example of architectural thinking about really two types. First type is type 5. Right now, correct me if I'm wrong if you don't agree, this is the type that's most prevalent right now as we build out agents that are task focused and process focused. Agents coordinating amongst themselves if you want to, if you want to think of it that way. And then here's the things that you should be concerned about and the things that you should be considering as you consider doing a type 5 approach. So one is agent coordination in the architecture, central control versus distributed. Do I have one central place to control what the agents do and how they do it and how they collaborate with each other, or is that more disparate? Is that going to be more distributed? I should also understand the tools and resources that I'll need to integrate into my system. An MPC is a good example of how you can wrap your arms around that, but before you implement that kind of an approach, you need to understand what it is you want to do with these tools and additional resources and how you want to access them and what kind of payloads you want to send to them and get from them. And that kind of leads us to understanding and putting in place or being concerned about guardrails and making sure that the guardrails are in place to prevent unintended actions and behaviors. So we can move on to the next slide. And this is more of a type 6 concern, or the concerns with the type 6 type of architecture, which is fairly new. And I would say kind of the future. There are a number of type 6 architectures out there being used today. Carrie had mentioned a few with OpenAI as they're trying to embed and integrate more in the enterprise. But there are a number of things that you need to be concerned about as you go to a type 2 architecture. It can be and typically is a lot more complex than the type 5. So again, need to think those things through, like cognition, like coordination, like orchestration versus choreography. So thinking these things through from a strategic direction becomes even more important. We move on to the next one, Carrie. So pattern thinking in AI architecture. Um, why does this matter? And I think I've kind of, hopefully I've made some bit of a case for that. It matters for a number of reasons, right? One, it's a proven way to develop good outcomes. It speeds development. It speeds bringing new people on to help you with your project. It gets everybody on the same page for all the stakeholders. And it standardizes the way you talk about your system. So in doing so, the quality of your system goes up as well as its ability to be adopted by others. We can move on to the next slide. And Terry, I will turn it back over to you.
Thank you, Bill. So just to emphasize, patterns is something that is paramount to architectural thinking. Patterns are definitely growing. There's patterns in cloud, there's patterns in software engineering approaches, and now we're talking about specific patterns around AI. In fact, as you build compound systems, you may need to understand patterns in all three of the domains I just mentioned. But the message here, which Bill emphasized, is that you don't have to learn all of this from scratch. You can find these patterns online in various blogs. You can find them in books. You can find them in GitHub. And these patterns, for the most part, have been instantiated into code. So you can actually accelerate your development by doing them. So this particular slide is really just a message that there are 4 to 5 must-know patterns. If you're going to use RAG, if you're going to access APIs, you got to know the tool integration pattern for your AI agent. You've got to understand how you're going to keep context from a memory standpoint, especially if you're going to have multiple agents interacting with each other. And then, of course, as you start moving to multi-agent, by the way, multi uh, agent system agents is sort of two distinct concepts. The fact that you're using multiple agents doesn't qualify as a type 6. It still could, and most likely it's probably a type 5. But agent orchestration pattern is going to be essential so you understand how multi-agent systems can be accelerated successfully. And of course, the retrieval augmented generation that we've talked about quite a bit is pretty common and pretty well used, and that's a pretty established pattern. And then, of course, the looks like it. I needed to make this a bit smaller, but the guardrail pattern, of course, is critical as well. So thank you all for attending. If you want to sign up for our full course, there's a discount code, Carry Bill. There's the link to it. Feel free to reach out to us on LinkedIn. Let us know your thoughts on this course. Let us know anything you'd like to see in a full course. And with that, we will open it up for questions. And Melody, do you see any in the chat that we should address? Bill, do you see any questions in the chat?
Yeah, there were a few questions, and I've tried to answer them, but let's go through one or two. So Isa asks, if I understand correctly, an MCP framework, is type 5. My opinion, Carrie, please weigh in. Yeah, certainly can be used in a type 5 solution, but also can be used in a robust type 6.
Absolutely.
Let's see, what else do we have? We've got questions about the links. I reposted the links again in the chat that Carrie posted a little earlier. So please take a look. Again, what we'll do for all of these is we'll send out the contents in the chat along with the recording of the presentation. Let me see if I can take everybody off of mute, and If you have some questions that you just want to ask, of course, go ahead. But of course, be mindful that others might want to have a discussion as well. So you should all be unmuted now or able to unmute yourself. So if there are any questions, please ask them, or I can call on you. So Lydia, if you're still on the call, and I hope you are, thanks for joining. Lydia does a blog on AI and AI maturity, really across education. Lydia, any questions?
Hey, this is Melody. I finally got off of mute here. There were a few questions that are now in the chat that came in. So one of them was from Michael Salami, says, how is everyone implementing your agentic observability harnesses? And does this align with how you're architecting your solutions?
So I think what the person's referring to is the AIScape framework when he talks about the agentic observability harnesses. I think that's what he's referring to. This is a relatively new concept that we've introduced, so I can't say that the industry at large is using it. We've introduced it here largely for the reasons I stated, so that all of us can have uh, productive conversations and stop using the word AI so generically. Secondly, although we'll publish more of this in the Medium blog, we'll put more detail in terms of how the framework can be used to develop skills, showing you how to progress uh, through the various types. But more importantly, to answer the question, we'll put in there some of the artifacts and describe whether they're essential or perhaps optional based on the type you're building. Uh, Essential or optional will really probably most likely mean the level of detail that's required. So the answer is we'll answer some of those questions as we evolve put more content. Actually, it's sort of an evolved concept, but we just need to publish more about the content, which we'll do shortly.
All right, if either of you could post a link to the class, we're getting questions about that as well. The next question comes from Isa, says, thank you guys. I'm experimenting right now with agents and everything makes sense. And a question from her as well saying, when we talk about this guardrailing, how do we measure its effectiveness?
Well, it's a great question. So the guardrail effectiveness is going to be measured in a few ways. One way is that uh, obviously before production rollout, you're going to, in advance, and this is, part of the thinking, you're going to identify what are some of the risks that you see with the solution you're building. And now you're going to develop a scenario, what some call a test case, to say, okay, how can I test whether this is being, whether it's whether you're trying to prevent a deep fake or whether you're trying to prevent whatever nefarious act, you're going to have to anticipate those and test for them and see if your guardrail is working. This is an evolving field in terms of guardrail, so it's something to stay abreast of in terms of the latest and greatest patterns in that area.
All right, next question. I am a data engineer starting out the AI journey. At which stage shall I start?
If you're a data engineer, I would suspect, because often when people use that language, they're not describing themselves as a machine learning engineer, but a data engineer. So that would be someone who's going to get familiar with data pipelines, help prepare work for data scientists and for data engineers. So if I understand that correctly, maybe a next step, if your choice goal is to be a data scientist, would focus on that role. Data scientists are pretty good in the math, they're pretty good in statistics, and they're pretty good in probability, and they're pretty good at the various algorithms that you use in machine learning, and also neural networks is becoming part of their toolkit as well. Contrast that to a machine learning engineer, which often has the background of a data scientist, but that's not their chosen field. They're more of a software engineer who happens to be really good at AI, specifically machine learning, deep learning, neural networks, and of course, today, large language models. So those are often two distinct career paths. Often you see data scientists more on the analytical side, more on the quick building of models side. The machine learning engineer, on the other hand, is someone who's going to be very skilled in the knowledge of cloud APIs, infrastructure engineering, because they're going to build the scaffolding necessary for not only those models, but more advanced models, more advanced types to work. This is a pretty involved question, so I hope that was a good brief answer.
And let
Yes,
me add one or two things to that. As a suggestion, I wouldn't take a procedural approach to this learning. Again, the question also calls out a good example of strategic thinking in understanding what your career goal is going to be. And as you're trying to decide that, there's a number of things that you can learn concurrently that might straddle both of those fields. So I would suggest to do that. Sorry, Melanie, please continue.
oh no, that's fine. The person who asked that question added in, I'm done on the preparation of data side of the AI applications. Now I want to build AI apps on top of it to build an end-to-end software.
Then I think you have your answer. Um, we know the
Okay.
direction you're going in.
Yeah, well, and just to add on to that answer, obviously with vibe coding, that can be a shortcut to building it. You'll have to determine whether that's sufficient to build the type of application you want. But if you really want to understand the coding aspect of this will require a different learning path. So I just mentioned two paths. One is a path where you're just trying to build the app. You might find yourself well suited for vibe coding in that case. But if you're trying to be the engineer who understands it and can use vibe coding in conjunction with other techniques, then you'll need to take a software engineering route to learning.
And just to clarify just a little bit, vibe coding, relatively newer term, but basically you getting an AI assistant or using AI to help you understand code, write code, describe to the whatever the AI system is, the code you want to write. And then it can generate some for you as a part of vibe coding. Great way to learn and sharpen your coding skills as well.
All right, the next question from Nikhil. There was a recent article by MIT, 95% of AI projects failed to achieve expected returns. Any comments on the whys?
Yeah, absolutely. That's probably pretty consistent with the post that we put in the chat around uh, the Rand Corporation. But I do think that it begs the question when people say and speak to failures is what type of AI system are we talking about? I would assert that when you're looking at the type zeros and type ones, the failures are probably less. As you start looking at the other types, which basically grow in complexity, we're probably seeing a higher rate of failure. I would suspect that the reasons are numerous. The number of reasons projects fail, to be quite blunt, hasn't changed in the last 50 years. We actually know exactly why projects fail. So let's start listing some of those reasons. Some of those reasons is a misalignment between business expectation and what was delivered. Now, that's where AIScape can help because we can begin to align those. What's another reason? I was on a project some years ago where we built a system successfully. It had some AI components as well. I happened to be at Mexico in the time when I get a call from a senior executive at the company I work for and called me and said, "Hey, you need to come down to this company that you built the system for because they're complaining about it." So I go to the company and I find out they're complaining that they had a market change in their environment and that market change required a pretty significant change to the system. They estimated the cost of that change to be about $50 million. And they're saying, hey, Kerry, I thought you future-proofed our system. And I said, well, let's go back to our architectural decisions and let's look at one of the decisions we made. And I showed them, I said, we made a decision here that we could do this or that. This would not future-proof, that would future-proof. You decided to take the cheaper route, and so it wasn't future-proofed. And that's why we are where we are today. That's one of the reasons of architectural decisions. So that's a reason right there. Time and cost, time and schedule pressure causes lots of projects to fail. The lack of architectural thinking causes projects to fail because either you haven't built the right infrastructure to deal with the scaling. So I don't want to try to list all the numerous reasons, but there are numerous reasons. I do think AIScape understanding whatever framework you want, but at least by beginning to be specific about what kind of AI system you're building gives you a leg up on success.
All right, in the interest of time, I'll go to the next one from Tony. It says, many of the architectural concerns you mentioned are the same as in other complex projects. How do you see AI changing these concerns or introducing new ones?
It's another great question. I think it changed them in a number of ways. Obviously, new patterns have been introduced. Not only have new patterns, but Bill talked about some of the concerns, for example, of a type 5. So the concerns have significantly changed. So even though we're still dealing with memory, even though we're still dealing with data, some of the age-old problems, how they're being used is significantly different. The scale is significantly different. And of course, some of you who've been paying attention to some of the software 1.0, software 2.0, software 3.0 thinking, that factors in as well. Don't have time to get into that today, but the point is that how we build software has a lot of similarities to what we did decades ago, but it also has significant differences. And we covered some of them by looking at the types of AI systems, building a prediction model. Let me just give a quick example. This is the difference between a type 1 and 2. So we built a machine learning model to do a prediction around diabetes. No problem. Suddenly we're now using deep learning and the organization wants us not just to build a prediction model, they're good with that, but they want us to see if we can now use neural networks, deep learning, to actually facilitate, accelerate doctors' work. This is different because now we didn't have the same problem before with non-AI systems, where we now, because we're dealing both with deterministic and non-deterministic systems, previously everything was deterministic, but now the doctors want to know, how did this system make this decision that I used to have to think about to make? So now we have to not only build it, but we also have to build sort of an ancillary technique so that they can go in and see why it did what it did. That's different. We never had to do those kinds of things before. That's just one example.
Very good. How do you see the ability of small and medium businesses to adapt to the capability you're describing?
So let me take this first, Carrie.
Please.
So a big misconception in small, medium-sized businesses is that that they're not big enough to implement this or to leverage this or adopt this kind of approach is definitely a misconception, right? So, in so far as the whole topic of this discussion, which is think strategically about what it is that you want to do with that system, and then come into building that solution either by selecting the right type or or the components. You do the same with small to medium businesses. Using AI, and no matter what your business is, no matter the size, is going to be a game changer for you. But again, if you take a reactive approach, throwing spaghetti up against the wall, if you will not get the best results. I'm seeing a good deal of work and adoption of of AI and AI systems by small and medium businesses to really increase their bottom line. A good deal of this that we're doing today.
I'm going to jump around a little bit since we're running tight on time. The next one is, how do we make AI architecture truly agile and not just scalable in a world where founders, VCs, and enterprise leaders demand rapid product delivery and ROI?
Another good question and a complex one. I would say a couple of things. One is that if we're talking about AI, and which we are, you're building more modular systems today than we ever have before. So there's a concept that's been outdated but still accurate called situational apps. There's also this concept of microservices. So one of the ways we create agility, and I'm presuming what the question is about when it says agility, but to me, agility means the ability, like an athlete or like a race car, to be able to turn on a dime. So in the case of AI systems, what that means to turn on a dime is to be able to address new needs, new problems, new challenges. So one of the ways to do that is to be able to plug and play things. And that's what we can do with microservices. That's what we can do with models that have been packaged into microservices. So there's a number of techniques to do this. I just given one, but that is one of the ways to do that. I think that the other thing to keep in mind is that typically the focus on ROI and so forth, my experience is often that today is a consumer-based app approach. But again, I believe that if we focus our attention on, is the app we're building a type 5, a type 6? Because if it's a type 6, a lot of risk. Cognition AI speaks to those risks. If it's a type 6, maybe we want to move away from an MSA type scenario to more of a compound AI system, which is very practical. So I hope I've answered the question.
How deep should we learn ML and DL now? Is that needed or just go to Gen AI?
Well, generative AI relies on the use of neural networks, the transformer-based architectures. It relies on large language models. I would assert that if I wanted to be a writer, I'm not going to just rely on a tool like ChatGPT or Claude to do my writing for me. I'm going to learn the basics. I'm going to learn grammar. I'm going to learn system structure, and I'm going to get more advanced. I'm going to learn character development. I'm going to learn plot development. I would say that if I'm going to be a writer, those are going to be essential skills. This is no different than in the world of AI. So yes, I want to understand generative AI, but if I'm going to be an engineer, I'm going to have to get my hands dirty, and I'm going to have to understand the base technology. It's interesting that there's a lot of conversation about the need or lack of a need for developers. The guy, I don't know if he's second in charge of AWS, but I think he reports to Andy. Just recently, a couple of days ago, came out with a statement that this thinking that we don't need programmers is crazy. Uh, and for every company that says that we don't need programmers, go to their website and ask the question yourself, why does their website, career site, have programmers for hire? So the point I'm getting at is, to answer your question, is you need both. You need to understand if you want to be an engineer. So it all varies. If you're going to be a product manager, you need to understand what ML and DL are, but you don't need to understand how to build them. So it's going to vary based on role.
Okay, let's wrap it up with one last question. Do you think the high failure rate, this is back on the failure rate question, is also due to the reactive FOMO-based implementations, like fear of missing out, implementations instead of thought-through systems design? How much of this is due to the AI tools and technologies itself that are evolving rapidly?
I think it's a fair question. I think it's both. I think some of it, if we go back in time when visual programming was a thing, I draw parallels to vibe coding, because what we're seeing with vibe coding is some really good outputs and the ability to use it to accelerate our work. But we're also seeing debugging problems. We're also seeing problems with being able to scale the code that's built. When I say debugging problems, not just bugs, but the problem for me to understand how to repair the generated code, the application that's been built. So yes, I think that just as there's been articles around how these large language models can make us lazy in terms of our thinking, a lot of these tools can make us lazy in terms of how we do engineering. So they can definitely accelerate us, but they're tools. They're not thinking engines. So again, hope I answered the question.
All right, there's a couple more deeply technical questions. I don't know if you want to address that, or should we wrap up and save that for the class?
Yeah, let's wrap up. We're at the top of the hour. Don't want to go too much further. I've kept everyone, and I realize just a few of you have stayed long. I appreciate it. And if there's any live questions for those who remain, go ahead and speak up. Otherwise, we'll close the call. Okay, thank you, everyone. And we'll shut down now.
Thank you all.